Hi Calculus 3 class. This is the second part on my series of power series, pretty much, right? So in the next three videos, we're gonna investigate three examples, and we will see how they are fundamentally different. So first example is this one. For what values of x is this series convergent? Now remember, to determine that, we have seen two tests so far. We have seen the ratio test and the root test. The ratio test involves a division. You divide successive two terms, while the root test involves taking the nth root of the expression of the general term. Now, as you can see, both of these factors, sorry, are at the power of n, which means that the root test is very convenient here to determine when that series converges or when it diverges. So here goes. Let's use the root test. Now remember, the root test is to write the limit as n is approaching infinity of the nth root of the absolute value of n. So if you have anything that's alternating or anything that changes signs, you can disregard it. But you have to be careful about the absolute values. As you can see here, everything is positive, right? N is an integer, positive integer. And oh, we still have to keep the absolute values over x though. So we have the absolute value, the nth root of n to the power of n, x to the power of n. Okay, then x to the power of n, since n is an integer, as you know, is going to carry the same sign as x. So we can simplify that a little bit. We can say that this is going to be the limit as n is approaching infinity of, we could say this actually, the nth root of n times the absolute value of x, all of it to the power of n. From there, keep in mind that the nth root cancels to the power of n in this case. You don't have to worry about domain here because the absolute values guarantees that you're going to have a positive number inside of an even root. So you don't have to worry about that, and n is pushed to infinity. So you cancel this, and now you look at this expression. Okay, so we have this as being the limit as n is approaching infinity of n times the absolute value of x. So it's going to be infinity times something. And as you can see, the only way this series can converge is if x is exactly equal to 0. So if x is exactly equal to 0, what happens? You get 0 plus 0 plus 0 plus 0 plus 0. So of course it converges to 0. So let's write that down. So if absolute value of x is equal to 0, so meaning x equal to 0, the series converge. Converges, and we can even say that it converges to 0 because we know that. Now, if x is any value other than 0, so if the absolute value of x is greater than 0, meaning that x itself is not equal to 0, then the limit as n is approaching infinity of n times x is going to be infinite. So we are in the second case of the root test. So the series diverges. And we can even write here second case of root test. So in other words, we can sum up our answer just by saying the only value of x for which this series is convergent is the value for which x is equal to 0. So x equals 0 is the only value of x for which this series converges. And this is your final answer. In the next video, we're going to see a different example with a different conclusion. See you there.